I think I'm recording. All right, so let's come over here. And now we're finding the rate constant. Gotcha. Okay, so again, the rate law. Are you getting sick of this? I hope not. It's going to pay you if you don't get sick of it. We found in a previous step, these were all raised to the 1. So I'm going to leave that off there. And I'm going to simply say this is iodate. This is hydrogen sulfite. And this is sulfuric acid. Okay. By the way, is it bothering you that I'm calling it iodate? I'm calling it iodate, and I'm also calling it potassium iodate. Why am I doing that? Because it's aqueous. And since it's aqueous, the potassium is nowhere to be found. The iodate's the only thing that's doing anything at all. And the same thing goes for hydrogen sulfite. So I'm calling it hydrogen sulfite or sodium hydrogen sulfite because these are the same thing. These are the same thing. All right. So let's go back to that. And by the way, I am aware that that may jar you a little bit. And in the comments, if this were open to the public, if there was 1,000 people looking at this, there would be at least several people that are going, "You're confusing me. This is terrible. This is the most confusing video I've ever seen." And they're saying that because they don't know that aqueous means that these two are the same thing. So actually, I'm trying to do you a favor. I understand that, okay? You can put that in the comments below. You can say, I hate you for making things uncomfortable for me, but it's actually a good way to learn, is to go back and forth between these because they are the same thing. So since this is only open for my class, I doubt there's going to be as many candid comments, but there may be some of that in your heart, and I hope that this is not discouraging for me to use both of these. Yeah, so that's what I'm doing, and I'm going back and forth on it. So, and that's the reason why. So let's look at this. My rate law. Now I know everything. Okay, this says for trial 1. Now for trial 1, I know the rate, and I know the concentration of iodate, and I know that, and I know that. This is the only thing I don't know. Okay, well, I'm actually very comfortable with algebraic manipulation. So I'm going to say K is equal to the rate in trial 1 over the concentration of the first thing in trial 1, concentration of the second thing in trial 1, and concentration of the third thing in trial 1. And I guess the third thing was potassium iodate. Yes, I just did it again. I know, that was HSO3 and then sodium or sulfuric acid. Okay, we've done this a couple times. So let's come over here now and let's go find the rate in trial 1 and the concentrations of those guys in trial 1. The rate in trial 1 was 1.454 times 10 to the -5. Over, okay, and the concentration of iodate in trial 1, I think everything was 0.004, wasn't it? 004, 004, 004. I think that's right. So let's put this in here. Trial 1. Is that right? Let's go back up to trial 1. 0.004, yep, 0.04, 0.04. Good, okay. Now we're going to be doing the rates later and the other things, so this is going to be a little bit complicated. Let's go back up here. We're doing K for trial 1. And we're going to say, no, I don't want that. What I want is this. 1.454 E minus 5 divided by I know it's just that cubed, but I want to put them all out, all right? And so this is going to give me 227.19. 227.19. 227.19. And that's a K, and this was molars. Let's put this is molars per second, and this is molars. And molars, that's molars cubed. So it looks like it's going to be molars minus 2, seconds minus 1. Not that it really matters, but maybe a future question is going to ask about that. But for now, let's put that in there. 227.19. Okay. And then in order to do the rate constant for trial 2, I'm going to switch out the rate for trial 2 and then one of the reactants. I think this was the one that went to 0.08. So I'm going to get that handy. The rate for trial 2 was 2.983. And that was that. Okay. So it's 233.05. 233.05. Wow. Beautiful. 233.05. $233.05. And we're going to do the third one now, and it looks like this rate, sorry about that, where's the rate for trial 3? Right there, gotcha, 3.367. And it's also, these are switched. I'm just going to do that as 0.08. I mean, this one goes to 0.4. I know this is, all I'm doing is switching the order, but that doesn't matter. And it goes to 263.05. Wow, nice. Look how these numbers are all about the same thing. 263.05. Okay. And we'll do the last one, 4. And that is 3.012. It's going to be about the same, isn't it? 012 times 10 to the minus 5, and then I'm not going to switch it. It's just there's one of them that's 0.08 at the bottom. And it gets to 235.31. Ooh, love it. 235.31. 235.31. Wow. And the average of these, of course, is going to be, I can't do that in my head, of course, 7.19 plus 233.05 plus 263.05 plus 235.31. Let's put these in parentheses and divide by 4. $239.65. Just beautiful. 239.65. Okay. Okay, write the overall rate law. Wow, we have the overall rate law now. Watch this. Its rate is equal to 239.65. And it was molar minus 2, seconds minus 1, times the concentration of the first thing, which is potassium. I'm going to write it all out this time. Sodium, hydrogen sulfide, H2SO4. Yes, okay. And the order was 1, 1, and 1. And so if it's 1, these are not parentheses, by the way. These are meant to be brackets. But since it's 1, 1, and 1, we usually just leave the 1s off. Okay, and that is the rate law. Good for you. Love it. Okay.